Let me welcome you to the 24th lecture of Drilling and Blasting Technology course. In this lecture, we will cover the basic of blasting and let us, as usual, let us retrospect the previous lectures. In previous lectures, we are being introduced with the explosive accessories, and we are trying to understand the properties of these explosives and accessories. And at this point, we are in a position to understand the requirement of these accessories. We should now understand how explosive fracture the rock mass also, and basically we will use our previous knowledge to in this course, and that is why our learning objective is to understand different blasting terminology first, and then to understand what happened when we initiate some explosive compound. And as usual, let us start observe a blasting video. Basically, we carry out this observing this video in every lecture, so that we can refresh our observations related to blasting, and these videos are available in the YouTube. Anytime you can see n number of videos available there. Particularly this video I have selected because this video is showing you in a different time scale than the actually it is happened. Say, as you are observing, few holes are there which is now being initiated and the blasting is carried out. Basically, this total process takes few millisecond time, but we are observing these videos in a different time scale, that means in a very slow speed manner. So, that is why you can observe how these initiations are carried out, how these waves are propagated, how the rock mass are being fractured, and how they are thrown in the front direction or upper direction, like that way. So, you can see in this video how the rock is moving in a very slow pace, but actually it is very high speed one. The videos are taken in a high speed observations, and then it is re-shown in a very low pace way. So, now probably you are observing the speed at which it is captured, maybe 10,000 frames per second, but we are looking at those frames per frame per second. So, basically we are looking in millisecond time. So, that is why as we are observing these are in millisecond time, we are able to see the movements of the different rocks, movements of the different particular fragmented boulders, movements of the gases. Even if we can feel the movement of the shocks also by the wave propagation in the ground, those are also very visible in this case. In this blasting, you have seen that simultaneous two phases are being blasted here. So, these videos are available from the Nitro Nobel explosive company, and this is available in the YouTube. N number of other videos are also available in the YouTube, and I request that please spend some time on observing this drilling and blasting videos in the YouTube. This will give you better understanding about the different blasting technologies, how those holes are charged, how the blasting is carried out. In this video you have seen the stemming ejection is there, that is why you can observe the flame, which generally in most of the good videos you will not find the flame is coming out from the blast holes. So, basically this video will give you somewhat understanding about the blasting operations. So, let us first start with the different blasting terminology, and as we carry out blasting, you have seen all those blasting videos, the blasting is carried out on the rock mass, and how those rock mass are situated? Those rock mass are situated as it is shown in the figure. So, rock mass are situated like this, and it is a tabular form, and this type of rock mass positioning is called bench. So, what is bench? Bench can be defined as a rock shelf which has a near horizontal face. So, this is the near horizontal face and a near vertical face. So, this is the near vertical face, and most of the cases when the face is under operation, you can have almost a vertical face. The near vertical face is there for the stability of the bench, but in most of the practical operation site you will find the near vertical face. So, basically bench is a rock mass and different benches formed a mine. You can see the video of it, you can see the picture of a mine where the different benches are formed. These different benches are formed to carry out the excavation of the rocks. So, basically mining is nothing, or rock excavation is nothing but the formation of the benches and excavation of the rock from those benches. So, basically bench is the rock shelf in which we carry out our excavation. So, our next terminology what we should understand, that is the drill hole, in fact, or blast hole. In fact, drilling is already covered in this lecture. So, drill, you know, we create the hole. So, that drill hole is called a blast hole when we insert the explosive inside the drill hole and allow the explosive to be detonated or to be exploded. So, a hole which is created in the rock bench to place the explosive inside it is called blast hole. So, initially it is a drilled hole, the drilled hole by getting the explosive inside that hole is called blast hole. And if you see in this figure, so this is the drill hole, and you can understand as this is the drill hole, you can see this is the bench height and drilled hole length is little bit more than this bench height. This additional drilling which is carried out in the drill hole is called sub drilling. So, this is the sub drilling length, this is the bench height, and so the total drill length is total hole length is nothing but the bench height plus sub drilling length. So, this is the, you can ask why we should need sub drilling. In fact, when we will cover up the explosive rock interaction, that time it will be better for you to understand this, that sub drilling is essential for a bench blasting. But in this condition you should know that as we are going for some additional drilling, so it is better to get the fragmentation to the whole rock mass, so that there will not be any rock portion left at this position. Instead of this, if we carry out drilling up to this, in those case what will happen, our fragmentation will become like this, and a portion of rock will remain at this position, which will allow to be a ridge, which will form a ridge at this position. So, this portion of rock mass will remain there after the blasting. To avoid this, we go for some additional length of drilling. So, at this point this is good enough for your understanding. We will understand it in better way when we will cover up the explosive rock interaction. That time it will be better for us to understand the sub drilling part. So, the next terminology what we should know is the charge length or linear charge concentration. So, what will happen, as we have carried out the drilling, you can see we have carried out the drilling and up to a certain length inside the drill hole we have inserted the explosive and rest part we left. So, this explosive which is inserted into the drill hole, that length is called charge length. What will happen to the remaining portion of the hole? In the remaining portion of the hole, we insert some sandy material or some plugging system at this position, so that on detonation of explosive, when the gaseous product will be formed, that should not escape from this opening. So, what we want? We want that we should insert explosive, inside the hole. The explosives are inserted here and the explosive is being detonated and the gases are kept locked inside the hole. So, that is why the gas pressure can be utilized for the throwing of the fragmented rock. So, for this purpose we insert explosive up to a certain length, which is called charge length. Rest portion of the drilled hole is kept vacant and we fill that with some inert material which is non-reactive to close the opening of the mouth of the hole, that is called stemming length. Linear charge concentration is the term we use, which is basically show what is the length of charging of the hole or length of placing the explosive inside the hole. So, linear charge concentration is basically the amount of explosive poured per meter of charge length is called linear charge concentration. So, linear charge concentration can be defined using this formula, where linear charge concentration L c is equal to pi d square, d is the diameter of the hole, pi d square by 4, that is the cross section of the drilled hole, and rho e is the basically the density of the hole. So, that is basically giving L c is basically giving the kg of explosive per meter of hole, if we are considering per meter of charged hole, only the charge length portion, if we are considering the 1 meter length as the unit. So, basically the linear charge concentration gives us the idea about that what is the charge concentration we are placing per meter of the drill hole length. So, if you are multiplying the charge length, into linear charge concentration, you will get the charge per hole. So, kg of charge placed per hole can be calculated using the multiplying the linear charge concentration with the charge length. Similarly, linear charge concentration can be achieved if we know the total charge placed in a hole and the charge length. By dividing the total charge with the charge length, we can get the linear charge concentration. So, our next terminology is the burden and spacing. The amount of explosive poured per meter is called linear charge concentration, and the burden is considered, sorry, there is some mistakes in the slide. Burden is basically the distance from the hole to its nearest free face is called burden. Basically burden can be considered as the resistance for the explosive. Basically, the purpose of the burden is that the explosive charge placed in the hole is of that much quantity which is required to blast this portion of rock which is having a width same as burden. So, the explosive, this charge is required to fragment the burden and the length of the bench height, that much portion of rock is required to be blasted by the explosive. So, burden basically the distance from the hole to the free face is called burden. Let us draw some figure which will be better for you to understand the spacing and burden. So, this is, consider this is a bench whose free face is this one and the holes are drilled in 2 rows. This is row 1, this is row 2. Okay. So, if you are considering this case, then the rock resistance from the first row of hole, from this first row of hole, the rock resistance is this much and this is called burden. However, if you are looking from this side, there are 2 holes in the first row of holes and this is the first hole, this is the second hole and the distance between these 2 adjacent holes is called spacing. Similarly, if you look at the second rows of hole, you will find out this is the second rows of hole and the first row of hole should be blasted ahead of the second row of hole and so after blasting the first row of hole using a delay detonator, you will find your free face will be shifted at this position and thus the burden for the second row of hole will be this one. Similarly, the spacing will be this one. So, always the burden is the distance from the free face to the hole or the new face created for the second row of hole, the new face created from there to the second hole position. So, these are the burdens and the spacings are the distance between 2 adjacent holes which does not show any resistance. But basically where is the importance of the spacing? The importance of the spacing is that if you are considering there are 2 holes at one row, but placed side by side, the zone of influence of blasting for the first hole is up to this and for the second hole is up to this. So, basically this distance is spacing which we this distance is spacing which we term as this is the distance of the spacing of the holes. This is essentially required because we consider the charge placed in a hole is basically fragmenting the rock volume the rock volume which is equal to burden into spacing into bench height. So, basically spacing is the distance between two adjacent holes and burden is the distance from the hole burden is the distance from the hole to the burden is the distance from the hole to the free face. Now, let us understand what happened when a column of explosive is being detonated. So, in this case you say this is a column of explosive. This is a column of explosive and consider at any instant of point t, the detonating front is at this position, Okay. So, let us go to a fresh page, draw the same diagram in that fresh page, then it will be easier for you to understand. Say you have a column of explosive, this is a column of explosive and at any point time any time instant say t is equal to 0, the shock front which is initiating the explosive is at this position. So, at t is equal to 0 your shock is at this position. This is the position of the shock. And what happened to your explosive when it is encounter a shock? Say we have already understood the explosive, we have already understood the explosive accessories and we have found basically it is not the flame, the shock is basically initiating the explosive. So, what will happen to the explosive if the moment it is getting a shock either from a detonator or from any other source. The shock is now received from the detonator to the explosive column, then the shock is travelled through the explosive column and at point t is equal to 0 time the shock is reached at this position. Then what will happen? The explosive at this position, this will immediately disintegrate. The internal bonding of the this explosive chemicals will be fragmented, will be destroyed and a huge quantity of shock will be released from this explosive position. So, what will happen? At t is equal to 0, the shocks will come out from this portion of explosive as it is encountered the shock throughout the all directions. Similarly, it will travel towards this direction also through the explosive column also and this shock will start the initiating the explosive. So, the shock is travelling in all the direction from the explosive and as it is moving through the explosive column, the explosive is being disintegrated and the shocks are being released in all direction from the explosive. But if you are considering at this position at t is equal to 0 shock is released, the explosive chemical is disintegrated in a number of elements, but those elements are not rejoined to form the gas. So, the gaseous products which is supposed to come out from this position is not there, only the chemicals are disintegrated into the elements, shock is released, the elements are trying to rejoining and shock is travelling. Say this rejoining of elements to form a gas takes some delta t time, and when the total chemical reaction is complete, reaction is complete at this position by the time shock has reached at this position. So, here T is equal to delta T, the shock is at this position by the time the reaction is complete and the gaseous products are coming out from this position. So, what will happen as T is equal to 0, shock is released from this place. At T is equal to delta T, when the shock is at this place, that time the gaseous products are coming out from the explosive. So, basically this gives the idea that there is a time gap, between the generation of shock and generation of gas from explosive. So, what will happen? The shock is released ahead of the gas when the explosive is under detonation. So, basically we are considering this when we would like to know what happened if we are sending some detonation into the explosive column, and you can see that this is the shock front at time t is equal to delta t, shock front at this position, t is equal to delta 0, t is equal to 0 at this position, t is equal to delta t at this position, and explosive reaction is complete at delta t time, and this plane say, let me reconstruct this sentence. If in this case you can consider at any point of time, you can consider the explosive column is being bounded by two planes. One is at this plane where the reaction is complete, another is this plane where the reaction is onset as the shock front is at this position, and in between these two the explosive already released the shock, but the reaction is under ongoing condition. That means, the elements are taking time to form the gaseous product. So, the basically this chamber is in one side it is the explosive reaction is complete, another side shock is onset, and ahead of that the unreacted explosive column or undisturbed explosive column is there. So, this in this chamber we can consider this is surrounded by two plane, this one plane is called shock plane, this plane is called CJ plane or Chapman-Joghurt plane. Any time we are describing the explosive properties, a detonating pressure is this much. So, all these properties gaseous energy released this much. So, all these properties are basically, if we are mentioning, those properties are considered to be at the CJ plane, detonating pressure at CJ plane, energy released at CJ plane. So, all these are considered at CJ plane. So, now basically from this lecture we understand that explosive on detonation, it is immediately disintegrated into the elements releasing the shock starting travelling all the direction, then it takes some time to form the gaseous products, and that means the release of gas from explosive detonation is a little bit while the release of shock. So, shock front is moving ahead. In fact, today's video, if you look back the video again, you will find out the shock is being propagated in all direction ahead. You can see the undulation on the benches because of the shock ahead of the fragmenting and releasing of the gas. So, that is why I request you to observe those videos, and basically we are able to understand that this position the energy in the form of shock is released ahead of the energy released as the gaseous products, hot pressurized gaseous products. So, shock is released ahead and gas released after the shock is released. Basically we basically we use this criteria for our blasting purpose while we are using the explosive for the fragmenting the rock, and we are able to utilize this time gap between the shock release and the gas release from the explosive for our benefit. So, there are few reference books, you can go through those books for understanding little bit more on this elaborations of this. I believe that you are able to understand the blasting terminology, what is burden, what is spacing, what is subdrilling, what is stemming, what is linear charge concentration, bench, etc. You are able to understand now, but if anyone is facing any problem, they can go through the glossary which is available everywhere. Okay. Thank you.